Welcome back, students. So here begins the most important part of the chapter, okay? The miscellaneous part, which has been divided in further three parts. And in all these, we will be studying some important properties of binomial, some basically the applications of binomial theorem, okay? How we are going to use the properties of coefficient, expansion, everything together, how to pick up the terms. So everything is going to be there in the coming three parts. In this, we will basically be studying two coefficients at a time, how we can combine the product or squares of coefficient. We will also be focusing some emphasis on differentiation of binomial expression, and in the coming parts we will be going after that. So this part will be limited to that. Let's begin with the part. Let's begin with the miscellaneous part. In this, we are going to study basically major true properties first, the sum of product of coefficients and the sum of square of coefficients. So what do we mean by sum of product of coefficients? Okay, now obviously sum, first word is sum, and then sum of what? Product of coefficients. Okay, till now we have discovered only, like we did in the previous one, sum of coefficients. It's talking about product of coefficients. Okay, now there has to be something in product, basically another coefficient. Maybe if I write MC something, maybe A, MC B, like that. So this thing we are gonna see, and then we will see sum of square. So this basically will be a consequence of this. Okay, now starting with the sum of products. Okay, in this again carefully note that we will be using, again, since it says product, okay, so we will be using two expansions. Okay, so first one will be 1 plus x, okay, and the other one, what we will do, replace x upon 1 by x. Okay, now if I write these two, okay, so this will be giving me nc0 x raised to power 0 plus nc1 x raised to power 1, and I guess you will be comfortable with the 1. Okay, goes like this. Now this will be nc0 1 by x raised to power 0. Now again note, this is the main crux here, that we are going like this. Okay, now when I multiply the two things on the left hand side, obviously my right hand side will also get multiplied. So let us first simplify left hand side and then see what we will get from the right hand side. So this will be 1 plus x raised to power n, and this will also be 1 plus x raised to power n divided by x raised to power n. So this will basically give me 1 plus x raised to power 2n by this thing. Okay, now the key thing here is multiplying the right hand side. Okay, so right hand side you will see nc0 x0 plus nc1 x1 plus nc2 x2. It will go like this, and the second one will be nc0 1 by x raised to power 0, then nc1 upon x, then nc2 upon x square. Okay, it will go like this. Okay, now in this one, this is again an expansion. Okay, now here if I write, now if I want to have coefficient of x raised to power r, okay, coefficient of x raised to power r, okay, in this one. Okay, so that actually if I write it like this, basically not r, it will be n plus r. Okay, both will be same because both will give us the same thing. Okay, yeah, so this if I write here coefficient of x raised to power n plus 1 here, so that will actually be the coefficient of x raised to power here, r here. Okay, now with this I cannot have x raised to power r. Why? Because everything is decreasing, so I at least need ncr x raised to power r from here. Okay, so that will be multiplied by this thing. So what I will have, ncr nc0, then The next term here will be NCR plus 1 x raised to power r plus 1. Okay. Now here what I am doing is I am finding out the coefficient of x raised to power r on the right hand side, and on the left hand side it will automatically become n plus r. Why? Because this n x raised to power n is already there. So 2n n plus r. Now this is the coefficient of x raised to power r on the left hand side. Okay. If I go by the expansion, okay, in this expansion n plus r will be the coefficient of x raised to power n plus r, and in denominator there will be x plus n. Okay, so this left hand side should be equal to right hand side. Whatever I am doing on the left hand side, extracting left hand side, that will actually give me whatever I am desiring on the right hand side. Okay, so very important to understand here that why we are not getting from this. I'll use some other color so that it does not get mixed. So if I am multiplying it with any term here, I am never gonna get x raised to power r. Why? Because here the powers are decreasing. And keep in mind that how we will be multiplying. Again, I'll open this up maybe here so that it does not get mixed up. We'll multiply x raised to power 0 with the whole thing, plus I'll take second one. This whole thing is basically this bracket. Okay, nc1 x1 raised to power whole bracket. It goes like this: ncr whole bracket, ncr plus 1 whole bracket. Now note here that this will be x raised to power r here, x raised to power r plus 1 here. Now what do I need from this bracket so that I get x plus r? Before this, not possible. But here if I have nc0 x raised to power 0 waiting to make it x raised to power r. Okay, so this is very important. For this I will need nc1 by x. This will make it as x raised to power r. So we are combining all such coefficients. Okay, and so first one will be nc0 ncr, then nc1 ncr plus 1, and it will go, and the common thing will be x raised to power r. Now this is the coefficient we are equating from both sides. On the left hand side this will be given easily by this one. So basically what we have obtained from here is 2n n plus r is equal to nc0 ncr plus nc1 ncr plus 1, and it will go on like this. Okay, so now whatever value of r I substitute, I can get the answer. Again, this can be written as 2n over 2n minus n minus r, which will be equal to 2n n minus r. So both the things are same because both will add up to get 2n. So both of them represents the same thing. Now I just need the r value. I can get the product of coefficients. So sum of product of coefficients, when we are talking about, we just take two expansion, and again these two are very important expansions. Okay, we combine these two, get the products, because question will be coming like this, that the values of maybe this coefficient. Now suppose it is given, you have to find the values of nc2. Now the key thing here is that the difference should be constant. Okay, the difference when you are increasing it by 1, so now here you are having 0 1 and that, you don't need to worry for that, means it can be taken care of. Okay, now only thing which you need is r, that is increasing uniformly. So you just, what you will do in this question, just put n is equal to r is equal to from here you just need to put r is equal to 2. If you put r equal to 2 here, you will get the answer as 2n n minus 2. Now this will be forming your, now depending on the n value you will get the answer of this. So again a very important thing. Now moving on to sum of square of coefficients, again in that case it's square of coefficients. Now we had nc0 ncr plus nc1 ncr plus 1, plus it goes like this. This was equal to 2n n minus r equal to this. Okay, now if I am requiring the square of coefficients, I can just put r is equal to 0. r0 will give me nc0 square plus nc1 square plus nc2 square, like this it will go on. Okay, and this will give me from here 2ncn. Now this is my coefficient, this is actually the sum of all things. Okay, so again key thing to note here is that we have converted this using the expansion of x plus 1 raised to power n and 1 plus 1 by x raised to power n. These two expansions we have used, we have multiplied them, and right hand side we have converted at this one, like what we are actually desiring. Okay, if I am desiring NC0 from this NC0, okay, that's fine. So what will be actually that? If I go like this, 0 0 x NC1 by x. Now if I am multiplying this by this, I am having x raised to power 0. I am multiplying this, I am having x raised to power 0. So this is basically coefficient of x raised to power 0. And when I am combining this, what I will be getting? Raised to power 2n by x raised to power n. Now from this I have to get x raised to power 0. So obviously denominator is x raised to power n. So here I will extract raised to power n. This will be my coefficient, and by now I guess all of you must be doing that, how we are getting x raised to power from the general terminology. So this was the general term, if you remember NCR. If I am talking about x plus y, it will be x basically raised to power n minus r, and y raised to power r. Now in this expansion, if I am saying 1 plus x, so I'm not worried about this part. I'm just worried. So coefficient of n will be n here and n here. Okay, and whatever the index, that will be modified. So that's quite easy, I guess, to understand now. Just pause the video right now and see it again. Do it once again what I have just done. Simplify the things. You will get to understand that how we are picking and applying the things. It's very easy. If I say a plus b into a plus b, you can just multiply a square plus ab plus ba plus b square. This is very easy. But when the numbers are infinite, same thing we are going. First we'll multiply this, then with this. Instead we are just looking at the coefficients here. Okay, we are not worried about x, y, because ultimately we are converting them, putting them some values. Okay, so one thing we have put 1, the other one which we are doing is equating the coefficient of that on both sides. Okay, since both the sides are equal, so powers of x will be the coefficients of those has to be equal. Okay, so next thing after this we will use differentiation. Okay, which is again very important. Now these all which we are doing in this part, in the last part we did some properties. These are all exclusive for JEE. Okay, nothing in NCERT or CBSE. Okay, so these are all the part of exclusively JEE. The properties, the sum of coefficients, everything we are going to use in detail. Okay, now use of differentiation again is a very critical thing. Okay, the question which we did maybe I guess 2 or 3 parts ago, in that one question was something like this: n by 2 r by 2, this one, and you got the series like that, 1 nc2 by 2, something like we were getting. So this could have been solved using differentiation or maybe integration. Okay, so we will do that also. So what does basically differentiation helps us, means how does differentiation, what difference differentiation brings to binomial. Okay, so this will be nc x raised to power 0 plus nc1 x raised to power 1, goes on like this. Okay, now if I differentiate both sides, what I'll get, nx plus 1 raised to power n minus 1, and this will be 0, nc1. Now next term would have been nc2 x square plus 2 nc2x plus 3 nc3 x square. It will go on. Okay, now you will say, what is the use of this? Okay, now what happens in many questions, you will observe that along with binomial coefficients there are some number written, maybe 3 4 plus 5 nc maybe 3, goes on like this. Okay, some numbers. Okay, now these numbers, they are actually, if I look at that the power of x must be 3 here, and then we would have differentiated and put the x as 1. Okay, if I somehow I can make here, suppose I'm just talking about this series only, that the series goes on like this, nc 1 3, I need this thing, 4 nc2 plus 5 nc3. Okay, straight away I am requiring this series. Okay, now what knowledge we have this expansion. Okay, now here I need 3 with c1. Now what I am getting with c1 here, 1. Okay, what extra I need? 2. So what I'll do in this step only, I'll make x square here, so that when I differentiate before this step, I am actually taking 3 here now, 3x square. Now this will also be having x square, so this will be twice of NC0 x, obviously x square. This will be having x cube now, but having 4. This will become 4 here. This will, next term will be having 3x5. Now what I've done is I multiplied by x square throughout. Okay, now the change will be only on this side. This won't be no longer be like this. This will be x square n into 1 plus x raised to power n minus 1 plus 2x into 1 plus x raised to power n. Okay, so again a point to be noted here is that now left hand side we need to remove the x's. So we just put x equal to 1. What we will get? 1 n into 2 raised to power n minus 1 plus x will get removed, 2 into 2 raised to power n. Now this is very simplified form, and the right hand side becomes the series which we were requiring. But again, don't forget this thing, the terms which are not there. Plus 2 is there, plus 3c1. Now this will be 4c2 because we have substituted x as 1 on both sides. This will be 5. It will become 5 now, not 3 anymore. 5c 3x, x will be removed, goes on like this. So this is what we were requiring in the question. So question will come like the value of this will be. So we have to use that. Okay, these are the coefficients. Okay, with coefficients, whatever the constant term you are looking, you have to make the power of that in this one. Okay, means in this expansion, again we will be using this expansion only. X raised to power 0 plus nc1 x raised to power 1 plus goes on like this. Now remember that when we will differentiate, whatever power here is will become the constant. So suppose if I would have required 6, 7, 8 here. Okay, now in this, what we will be doing, we will be going with multiplying by x raised to power 5, so that this becomes x raised to power 6. Okay, now again note that we are not gonna the sum difference is not gonna be 1 always. Okay, so what do we do in those situations? For example, if I am required that I'll continue it here, that suppose if I am requiring this thing nc0 x raised to power 0 plus nc1 x raised to power 1. Now suppose in the question, instead of gap of 1, it is series required is this 3c maybe 4c2 plus 6c3 like this. Okay, now what do we do? In this case, even if I do x square of this, in this I will be having 3 only. So here what do we need to do is that we will change, instead of multiplying this by x, we have to change the power of x. If the gap is 2, we will use x square here. Now what advantage it will offer to me? Here it will be x raised to power 0, x square here, x4. Now this is having already the difference of 2. Okay, now because whenever I am multiplying by x something here, okay, that is only changing uniform. The gap is decided by these powers, x raised to power r. Okay, so gap is decided by this power. Okay, so if I gap is 3, suppose 3c1, 6c2, 9c3, and it goes like this. If I require this, what I'll do? Okay, gap of 3, I'll first use this expansion, x cube raised to power n. So this will be nc0 plus nc1 x cube plus nc2 x6. Okay, now since the coefficient required is 3, I'll differentiate it and I'll get 3 nc1 x, I'll put 1 plus this will be 6 nc2. Now suppose if there would have been 4, 7, 10, then what we would have done? Instead of differentiating initially, so the coefficient will be decided by the power with that coefficient, power of x with that coefficient in this expansion, and the gap will be decided by the power of x. So two important things to note in differentiation, that whenever we are getting any, suppose any value is asked, we will observe two things, okay. What is the coefficient with the NCR thing? If I am requiring 1, what is the power here? We have to first adjust that, then we will see the gap. According to the gap between the coefficients, we will use the power here. If the gap is 1, x raised to power 1 here. If gap is 2, x raised to power 2 here. And depending on this, we will just multiply outside and both sides, so that when we differentiate, that coefficients comes out of that thing. So this is very important differentiation, that it will help you in understanding many things. Integration we will be continuing in the next part, obviously. So but for this video, the differentiation parts need to be very clear. Just practice some questions on this, based on this, maybe from test paper or whatever source you are having. Other than this, whatever books you are having, specifically go and solve some questions based on differentiation. If you have any doubt in this topic, you can post it for free on askIITian website. For this, just visit the askIITian.com, and there you can visit discussion board. It will direct you to Ask Expert, where you can select the category, and according to the category, post your question and click the Get Answer button. Experts at askIITian will answer your query within 24 to 48 hours. I guess now you have tasted a starting of complexities, okay. So life is not gonna be so easy in binomial, and you must work hard and try yourself to simplify the things, the derivations which were done, okay. Because what happens while understanding, most of the students, they think, okay, it's so easy, but when you do, once it's over, and when you are trying to do it yourself, you'll just scratch your head and say, oh my god, what the hell was that? So please, this is a recommendation, that please do all the derivations by yourself and revise all the properties, and stay tuned for the next part.